Okay, so children, today we will be learning about electrolysis. This is one of the most important topic for our syllabus. Here, before we go in detail to this electrolysis, what we need to learn is the components which are going to be used in this electrolysis. Okay, so here this diagram you can see. Okay, in this container you can see here this is the liquid part. Remember, this liquid part can be of any solution. Remember here, this solution is always of ionic compound. Okay, it is of ionic compound. Here, why ionic compound? Why not covalent compound? Because only and only ionic compounds are forming free ions. For example, I can take here the solution of sodium chloride. So you can see here this sodium, due to donation of electron, it has formed positive ion, and this chloride ion which is there, due to acceptance of electron, it has formed negative ion. Okay, so due to this ions they can move, but in covalent compound they do not form ion, they do not have any kind of charge. Okay, so we cannot do electrolysis for covalent compound. So this solution part or liquid part which is there is called electrolyte. This is called electrolyte. Okay. After that, you see these rods are there. You can see here this one as well as this one. They are said to be electrodes in general. They are called electrodes. So these are the electrodes. And here you can see this is the power supply, or you can say battery. Okay. Now this is showing positive terminal. So here this positive terminal is attached to this rod, or you can say this terminal. So this is called anode. Okay. This is called anode. Here, this is attached to the negative terminal. So this is called cathode. Okay. Yeah. Now, you are aware of this charge particles are going to be attracted towards their respective electrodes. So, as you know, this is the negative terminal. Okay. This is negative terminal. So, here positive ion will go. This is negative terminal. This one is negative terminal. So here positive ion will go, and here at positive terminal this negative electrolyte, or you can say ion, will go towards that. Now understand here. I said this is the solution of sodium chloride. But since it is solution, it will have presence of water as well. So here, due to electric current, this water is also being split into H plus ion. Okay, it is being split into H plus ion and OH minus ion. OH minus ion. Okay, so in total there are 4 ions present if this electrolyte is of any solution of ionic compound. Remember one thing, only and only in the form of solution, as this free charge particles, or you can say ions, can move. Okay, so only and only in solution form, or they must be in molten state. Okay, this can be in molten state or in the form of solution, because free ions you can get only and only in this physical nature. Okay, either in the form of solution or in the form of molten state. But if this ionic compound, say NaCl, is in the form of solid compound, so this cannot conduct electricity. Okay, because free ions you are not getting here. So for electrolysis they must be in the form of molten state or in the form of solution. Okay, so this much we studied. Now we will see here how this electrolysis takes place. So whenever this electric current is passed through it, so there will be flow of electrons. Remember why this cathode is the negative, because concentration of electron will be maximum on this side. So these electrons are moving from cathode to the anode. Okay, remember here there are two kinds of movement taking place. This charge particle which are there, they are moving in the electrolyte, and electrons are moving outside the circuit. Okay, outside the circuit, who are in motion, who are moving, they are the electrons. Inside the electrolyte, who are in motion, you will say this charge particles are in motion. Understood? So this is how principle of electrolysis is. Okay, what happens due to supply of electric current? To supply of electric current, these ionic compounds which are there, they can be broken. Okay, electro means electric current, lysis means splitting. So splitting of this ionic compound takes place because of usage of electricity as energy. Okay, so now in next slide what we will see is which particle is moving towards which electrode. Okay, so what we will do, we will just copy this into next slide. So you can see here what we will do. You are aware of what we are doing now. See here, as I said, this is the solution of sodium chloride. So here, how many particles are positive? I can just erase this to make more space, to get more space. Yeah. Okay. So you are aware of what is electrolyte, what is electrode. Okay. Here, just for your information, I will keep this one as anode and this is the cathode. Yes. So here in total, how many positive particles are there? So you will say sodium ion Na plus and H plus. Now, how many negative ions are there? So you will say Cl minus and OH minus. Now children, see, you are aware of what? Positive will go towards negative electrode. Okay. That is why positive particles or positive ions are called cation, because they are going towards cathode. Okay, so they both are cations. Similarly, this negative particles or ions which are there, they will go towards anode. That is why they are called anions. Okay, but out of them, out of this sodium and hydrogen, only one will go towards cathode. Same way, out of this chloride ion and OH minus, only one will go towards anode. But who will go? For that, what you have to remember is among metals, among positive ions, the one which is lesser reactive, that will be going towards cathode. Now tell me here, sodium or hydrogen, who is more reactive? So you will say sodium is more reactive. Sodium is more reactive. In other terms, I should ask, who is less reactive? So you will say hydrogen is less reactive. So who will go towards cathode from this electrolyte? Yes, correctly said, it is hydrogen. So hydrogen ion will go towards cathode. Okay, hydrogen will go towards cathode. Why? Because it is less reactive. But remember, this is, we are taking only and only for positive particles for metals. So the one who is less reactive is going towards cathode. And for that reactivity series we have to remember. Okay. Now, out of this negative ions, who will go towards anode? Yes. Who will go towards anode? So for that, if they are halogen, fluorine, chlorine, bromine, iodine, they are coming in halogen group, group 17. You have to remember here, if it is concentrated solution, for example, concentrated solution of sodium chloride is called brine. Okay, it is called brine. So suppose this is brine. So here, who will go towards positive electrode? So yes, you are right. Chloride ion will be going towards anode. Okay, understood? But remember, it is only for the concentrated one. Okay. Now, if in exam it is asked where oxidation takes place, where reduction takes place, for that what you need to do, you will do half equation. So what is happening here at anode? Okay, so we will write at anode what is happening. So here at anode, who is going there? So you will say chloride ion is going. So chloride ion, it goes towards anode, and what is this going to do? So this chloride ion will go there and it will give away that electron. You can see these electrons are coming here. So chlorine will be formed. So this is the chlorine atom. How come? Because it has donated its one electron. But chlorine atom cannot exist in monoatomic form. It will form covalent bond. That is why two chloride ions will be there, which will be forming chlorine molecule and releasing two electrons. Got it? Same way, what happens at cathode? So you will see here at cathode, who is going there? You will say hydrogen ion. So hydrogen over there, what it does? At cathode, you can see these electrons are moving and coming here. These electrons will be accepted by this hydrogen and it will be forming hydrogen atom. But again, hydrogen is also gas, non-metal, it cannot exist in monoatomic form. So two hydrogen ion will be going towards cathode, which will accept, this is going to accept or gain electron. Remember, generally we know that metals or positive particles are formed due to donation of electron, but here they are accepting those electrons back. Similarly, this negative ions, they are forming this neutral atom or molecule because of giving back those electrons what they had taken. So here this hydrogen ion is going to accept two electron and it will form hydrogen molecule. So you see children here, chloride was negative. It is forming a molecule with neutral charge. Remember, an atom or molecule will have charge neutral. So from negative or minus to zero. So what is this? This is oxidation. Here what has happened? Here it is oxidation. Remember, this is oxidation. And here from positive, it is forming zero. From +1 to 0. So what is this? Reduction. So you can say here at anode, oxidation will take place due to giving back this electron, and at cathode, it will show reduction due to gain of the electron. Okay, so this is how this hydrogen gas will be formed at cathode. At cathode, here hydrogen gas or bubbles will be formed, and at anode, chlorine gas will be formed. Okay, so this is how electrolysis of sodium chloride is taking place. But what about the sodium and hydroxide? So they are inside this electrolyte only. So this sodium and hydroxide ion, they will be forming sodium hydroxide. So here, when we do electrolysis of brine, we are getting three products: chlorine at anode, hydrogen at cathode, and sodium hydroxide at this electrolyte. Okay, so children will do the other examples in next slide. Okay, thank you.